So hello everybody, this question says the cubic fx is equal to x cubed plus bx squared plus qx plus 12 is exactly divisible by x minus 2. It has a remainder 12 when divided by x plus 1. And show that fx is divisible by 6 for all integers n. So for the first bit, since it is exactly divisible by x minus 2, then f of 2 must be equal to 0. So we can write f of 2 as equal to 2 cube plus p times 2 square plus q times 2 is 12, and that equals 0. So 8 plus 4p plus 2q plus 12 is 0, or 4p plus 2q equals minus 20. You can simplify it. 2p plus q equals minus 10. So this is the first bit. Next part says that it is remainder 12 divided by x plus 1. So then if there is a remainder, that would mean that f of minus 1 should be equal to 12. Okay, so what I can do is, replace x by minus 1. So f of minus 1 equals minus 1 cube plus p times minus 1 square plus q times minus 1 plus 12, and that is equal to 12. The 12 and 12 cancel out. We're left with minus 1 plus p minus q is equal to 0. So p minus q is minus 1. So p, is equal to 1. So p equals q plus 1. So I can substitute it here. P equals q plus 1. So I can write 2 times q plus 1 plus q equals minus 10. So 2q plus 2 plus q is minus 10. 3q is equal to minus 10 minus 2 minus 12. Q is equal to minus 4. So if q is minus 4, p is minus 4 plus 1, that is minus 3. So we get from the first two parts of the question that p equals minus 3 and q equals minus 4. So then let us actually write the equation down, see what we get. So then what we can write fx as equal to x cubed plus px squared, so that's minus 3x squared, and then plus qx, so that's minus 4x plus 12. So that's fx now. Now we are given that x minus 2 it's exactly divisible by x minus 2. Hence x minus 2 is a factor. So therefore, if we're divided by x minus 2, then we should be able to find the other factors, and then we can check if it is divisible by 6. Okay, so we need to find the other factors. So then I need to divide it by that. So x minus 2, x cubed minus 3x squared minus 4x plus 12. So I can write here x squared, then x cubed minus 2x squared, subtract, I get minus x squared minus 4x plus 12, then minus x will give me minus x squared plus 2x minus, so then I get minus 6x plus 12, and I can just write minus 6 will be minus 6x plus 12, and I get 0. Hence I can write fx as equal to x minus 2 times x squared minus x minus 6. So I'm going to factorize x squared minus x minus 6, and I can write this as x squared. So I can say factorize. So then x squared minus 2x, plus 2x minus 3x minus 6. That is x times x plus 2 minus 3 times x plus 2. So x minus 3 times x plus 2. So I can write fx equals x minus 2 times x plus 2 times x minus 3. So that's fx. So now we need to do the final bit to show that it is divisible by 6 for all integers n. Integers, mind you, they've said. So then fn can be written as n minus 2 times n plus 2 times n minus 3. So if that's the case, then I can, you see, we can check, to be divisible by 6, it has to be divisible by 2 and 3, okay? So to be divisible by 6, it must be divisible by 2 and 3. So now if n equals, suppose 5, then you see f of 5 will be 5 minus 2. So that is 3 times 5 plus 2, that is 7, times 5 minus 3, that is 2. And that is divisible by 3 and 2. Or 6. Now, if you were to take, so one of these numbers has to be even, and which it will be if it's like n is 5 is an odd. If you take any odd number and you are adding, you're taking off 5, how do I say, if you are taking off another odd number, so odd minus odd would give you even. So you can try with any other number, so you will get even. So it has to be, it could be, say, if we do 13, so 13 minus 3 is 10. But 13, if you do 13, so for example, if n is 13, then f of 13 would be 13 minus 2, that is 11, multiplied by 13 plus 2, that is 15, and multiplied by 10. So once again, you see this is divisible by 6. Because if you divide by 6, it is, 3 times 5 is 15, 2 times 5 is 10. So it's divisible by 3, and 2 is divisible by 6. So hence we can say that fx is divisible by 6 for all integers n, because one of them will always be even. So we can say, we can add another line that one of these is always even and another is always divisible by 3. Hence proved.